Welcome back to All This Math. This is Professor Parker. Make sure you subscribe to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below. Make sure you share this video with somebody else, or maybe 2 or 3 people, or whatever, right? Also, on Amazon, my book is available. How to Use All This Math, Volume 1. It's a good resource guide for parents and other people that want to prepare their children or children that they care about for math class. All right, look into that. All right, what's today's lesson? Today's lesson, we're dealing with piecewise functions. Piecewise functions. Now, why are they called piecewise functions? Right? We got to get into the habit of understanding why certain aspects and topics of mathematics have the names that they have. Because oftentimes, if we understand the name they have, that and where the name comes from or the etymology, we understand what to do when we see problems involving them. Now, with a piecewise function, we're looking for a piece to graph a piece of each of the functions that we're given. Now, look in this example. We got 3 different functions. 3 different functions. Don't let that intimidate you. Don't let that intimidate you. We got 3 different functions, right? 3 different functions, right? Asada, pay attention. So Asada's not in this video, right? So those of y'all that are familiar with the channel, you know my daughter Asada. You've seen her in some of the video content. She's not in this video, but what she's supposed to be doing is taking notes, right? Behind the scenes, taking notes. And she's over there on her phone, just like these kids in school, be distracted on their phones. That's why they don't be learning math. So my own daughter's guilty of it, right? Happens to the best of us. All right, anyway. So we got 3 functions here, right? F of x is equal to 2x plus 1. F of x is equal to 1. F of x is equal to negative x squared. All right? Now, this is a linear function, right? Meaning the graph is going to be a straight line. The root word of the word linear is line, right? This is also a linear function. F of x is equal to 1, right? So the root word, it's going to be a linear, right? Because whenever you have a function where you only have a constant on one side of the equal sign, that means that your graph is going to be a straight line. Also, f of x is equal to negative x squared. This one is different because this is quadratic. Your biggest exponent you see that the variable carries is a 2. So therefore, this is a parabola, right? It's a parabola. The graph is going to look like McDonald's arch or McDowell's arc from Coming to America, right? Or it could be upright. In this particular case, because this is negative, this is a negative x squared and not a positive x squared, it's going to open concave down. Concave down. All right, concave down. All right, so what do we do first? So we're gonna do this because we want to graph f of x equals 2x plus 1, but we only want a piece of it because we're dealing with a piecewise function. We want a piece of this function, right? Where's the piece at? We want the piece where all the x values are less than 1. Not equal to 1, not greater than 1, but less than 1. All right. So first, you got to know how to graph functions. You got to know how to graph linear equations or linear functions. You got to know that. You got to know how to identify the y-intercept. You got to know how to identify the slope and find your first point and find a second point, maybe a third point. You only need a minimum of 2 points though, but you got to know how to do that. When we're doing math gets successively more complex. All right. You got to bring some stuff to the table, right? Just like when you're playing sports. You want to play football on a high level, basketball on a high level, baseball on a high level, you got to already bring certain athletic ability to the table. And then a coach can help you to develop and become more advanced, but you got to bring certain ability to the table. Like you got to already know how to run, right? You might have to already know how to catch a baseball with a glove, catch a football when somebody passes it to you, catch a basketball, right? When somebody passes that to you, do a layup. You got to already know certain things. So in order to do this, you got to already know how to graph linear equations. All right, so we got f of x is equal to 2x plus 1. So I don't particularly like to use function notation. I prefer using y instead of f of x. So let's do this. I'm not going to use black for this. Let's use green. Matter of fact, let's use red. So I got y equals 2x plus 1. And then I'm going to graph that, right? So the way I graph that is this, right? Those of you that are watching this video but are familiar with this, you need 2 pieces of information basically. This is our slope. This positive 2 is our slope, the coefficient of x. And this 1 out here is our y-intercept. All right, y-intercept, slope. So a y-intercept is 1. So therefore, I'm going to draw a point at positive 1. All right. I'm going to use black because I'm going to ruin my marker if I put red on top of black. All right. So watch this. My y-intercept is 1, so I'm going here with it. I'm drawing a point right there. Right? And then my slope is 2. So I'm going to have m is equal to 2, but I'm going to make it look like a fraction. Make it look like a fraction. That's going to help you. And then I know my vertical movement and my horizontal movement. Now, how do I know I'm going up? Because the 2 is positive. If your numerator is positive, that means you're moving up. If your denominator is positive, you're moving to the right. And it would be the opposite if the numerator or denominator was negative. For example, if my numerator was negative, I would be going down. If my denominator was negative, I'd be going to the left. All right. So from this point, I go up 2 spaces. I follow directions. This is directions. The slope is a set of directions. I'm going to go up 2 spaces, and then I'm going to go to the right 1 space. Up 2, right 1. That's what the slope is for. So I'm going to go from this point, 1, 2, right 1. Boom. That's my second point. Make sure it's lined up. Yeah, that's cool. And then I got my 2 points, right? I got my 2 points now. Now I can draw my line. All right. But watch this. I only want a piece of this function. Normally, under normal circumstances, I would take my ruler and I would draw a line through these 2 points from up here in the first quadrant all the way down here to the third quadrant. First quadrant, third quadrant. Just so you know, first quadrant goes counterclockwise. Quadrant 1, 2, 3, 4. That's going to mean a whole lot to you when you get into trigonometry. All right, dealing with the unit circle and all that, which is more fun stuff. I got videos on that too. So anyway, but I only want the piece that's less than 1. I want the piece that's less than 1. All right, so that means that normally I would draw this line like something like this. I would do like this, right? But I want the part that's less than 1, where the x is less than 1. So let me find 1 on the x-axis, which is right here. And then what I'm going to do is I'm going to replace this point with an open circle. Now, why am I doing it? Right? More teachers should tell why, not just what. A lot of teachers and professors of math are very good at telling what to do, but they don't ever tell you why. And because they don't tell you why, it's difficult for students to remember what to do. If you tell why something happens, then I can remember. It's easier for me to remember what I need to do, as opposed to you just telling me what to do, and then I don't know why, so I'm not able to retain the information as well or commit it to memory. So anyway, let's do this. So if my boundary point, right, is positive 1, and I know that I only want the piece where the x values are less than 1. I find this, and I'm going to erase this, right, and I'm going to erase this point, and I'm going to put an open circle. Put an open circle, right, and then we'll put an arrowhead at the end. All right, so now I got a piece, right? The whole function f of x equals 2x plus 1 would be a vertical, but not a vertical, diagonal line that goes from down here, third quadrant, all the way up here through the first quadrant, all the way up through the Asada Shakur picture, right? That's where it would normally go. But I don't want the whole thing. I just want a piece. And what piece do I want? The piece that where the x values are less than 1, because that says x is less than 1. Math is a language. You got to know what the symbols mean. All right. So we want this part, right? We want that part. Now let's go to this next function. Y equals 1, or f of x equals 1. Now, why did I say y equals 1? Because f of x and y mean the same thing. F of x and y mean the same thing. So I'm going to graph y equals 1. Now, what do you do whenever you have an equation or a function where you have a y value, an equal sign, and a constant? That is going to be a horizontal line. It's going to be a horizontal line. All right. But our domain restriction, or our domain, says that x equals 1. X is not greater than 1, less than 1. X equals 1. So normally we would find the y-intercept. This 1 is also can be considered to be the y-intercept. Normally we would just go to positive 1 on the y-axis, and then we would just draw a point, and then we draw a horizontal line, right? But we're not going to do that. It's not actually going to be a line. How do you know it's not going to be a line? Because the domain says that x equals 1. So it's only going to be a point, a single point, right? So y equals 1 would be a horizontal line going like this, going like this, going like this, going like this. That's what it would be. But because we dealing with just a point where x equals 1, we're just going to draw the point right there. And that's that. That's all we had to do for this function. So for the first function, we had to draw this piece of the line. For the second function, we had to draw this point right here, right? Now, for this last one, this is a parabola. This is quadratic. It's not linear. It's not linear, right? So since it's not linear, what we got to think about, we got to have some familiarity with quadratic equations or quadratic functions, parabolas. If it was y equals x squared, it would open up like this, right? Like a U almost, right? Not a V. Wouldn't look like a V. A V is an absolute value function, and that's not what we're dealing with. It will open up like a U, right? But because it's negative x squared, that's called a reflection. We can think of that as a transformation. It's a reflection over the x-axis. See? X-axis, y-axis. A reflection. So instead of it starting at the origin or having a vertex at the origin and going up like this, it's going to flip upside down. Why is it going to flip upside down? Because of that negative sign right there. That -1. This really is a -1, right? That -1 is going to make it flip upside down. All right. So it's going to go like this, right? All right. But let's think of some points, right? Now, we're concerned with the piece of it where x's are greater than 1, right? So let's do this. Let me do this. Let's do y equals negative x squared, and let's use a table of values. So let's pick some x points. So let's say, okay, well, what's y going to be when x is 1? So since 1 is our boundary point, let's use that. Let's use that. Since 1 is our boundary point, let's throw the 1 in. And this is why we also got to know the order of operations. We got to also understand the order of operations. And in the order of operations, we have to deal with this exponent before we deal with this negative sign. Exponent first, then the negative sign, because the negative sign really represents multiplication. It means -1 times whatever this x value is. So that looks like this, -1 squared. So you do the 1 squared first. And I got many videos on this channel on the order of operations because it's a very serious thing, right? We must know the order of operations. So we got 1 squared, which is 1. Then multiply that by -1 or the negative sign, which means this is -1. And then what if we had a 2? 2. That's going to be -2 squared. So we got 2 squared, which is 4. Then we got -4. Right? So we got 1 and -1. Then 2 and -4. All right. So let's do this. Right? Let's do this. Let's do this. Let's do this. So, all right. So for my x, if my x value is 1, my y value is -1. Right? But look, I'm going to do the open circle. Why am I doing the open circle? Because I'm concerned about the piece where the x values are greater than 1, not where they're equal to 1. If it was a shaded in circle, that would mean that x was equal to 1. But we following the instructions. It says, just like when we cooking, when you follow a recipe, you're following instructions. You're following instructions. So look, x is greater than 1. So that means that this is like a boundary point. So we don't shade that in, right? And then over here, what happens when x is 2? When x is 2, because look, 2 is greater than 1, right? Yeah, it is. X is greater than 1. 2 is a number that's greater than 1. We could have used 1.1, 1.5, 1.6, but I'm like, I don't want to deal with decimals if I don't have to. It makes things more complex, right? Let's avoid that for now. All right. So now we got 2 squared, which is 4. Then we multiply that by -1, which is -4. So I go over here to +2, and I go down -1, -2, -3, -4. Right? So if I was graphing this whole parabola, it would have a vertex at the origin, 0, 0, and it would go like this, but then it would also go down like this on this side. But I don't care about the piece on this side. I only care about the piece that is greater than 1, right? Greater than 1. So this is what it's going to look like. And it should be curved. That's what it's going to look like, approximately. approximately like this. So look, it's a piecewise function. So we got pieces of three different functions, right? It kind of these functions always remind me of watching Martin, right? Old episodes of Martin with Shanae, when Shanae's hair, you know what I'm saying? She would have like there were certain episodes where she might have like, you know what I'm saying, like three hairstyles in one. Like she might have a side ponytail in the back or to the side. She might have some finger waves in the front. She might have like a terror weave over here. If you're from Philly, you know, you grew up in Philly, I didn't grow up in Philly, but I've been here a long time. You know what a terror weave is, right? You know, from back in the day. But that's what this is, right? It's a lot going on. You got like it looked like a straight line over here. It's a single point right here. It's a half of a parabola over here. It's a whole lot going on, right? That's what piecewise functions look like. Because you're taking a piece of three different things. Almost like imagine, you going to the, a buffet or something, and you taking different servings of different types of food. You got a whole lot of stuff on your plate. It might look wild. The food might taste good, but it might look wild to somebody else looking at your plate. You know what I'm saying? The way you be like mixing up certain items and whatnot. So that's what a piecewise function is, right? And the reason that we need to understand piecewise functions is because in life, like we use algebra to model real life situations. That's what we use algebra for. That's one of the reasons we use algebra to model real life situations. And in life, everything ain't always nice and neat. Everything ain't always nice and neat. So because things aren't always nice and neat, then we have to be able to represent them. Sometimes in life, we got to put different things together. Things that seem like they don't have nothing to do with each other. Like maybe these three different functions might be a model for three different experiences that you might have, right? At three different times of your life or three different times of the day. And we might be trying to come up with an algebraic model in order to better understand our mood patterns and our feelings and whatnot, and what causes our mood, right? Some of y'all that might, people that might go to therapy might be trying to figure these things out. We can use algebra to figure these things out, right? So then we can better predict, like, oh, okay, I know whenever I do this, I feel this kind of way, or I know whenever I eat this type of food, I feel this kind of way. So if I feel bad or my stomach starts to hurt or I start to get angry, maybe I shouldn't eat that, right? But then when I eat something else, I feel a different type of way. Different functions, different situations, in different times, right? So this is the purpose of knowing how to do this. And also, it's just good to know how to solve problems, right? It's good to know how to do things. Doing algebra enables us to understand how to solve problems and how to just figure things out and do things. And also, I neglected to mention earlier, Asada is welcome here. Shout out to Asada Shakur. If you're not familiar with her autobiography, please read her autobiography, Asada, an autobiography. Get familiar with her work. She was a member of the Black Panther Party for Self-Defense. She used to work with the Free Breakfast Program at one point, among many other things. She also became a member of the Black Liberation Army. But definitely, do your research on Asada Shakur. Grab a copy of her autobiography, read her autobiography, and make sure you subscribe to the All This Math YouTube channel. Like I said earlier, drop a comment down below. Please like the video, share the video with as many people as possible. People that might, be in a pre-calculus class or algebra 2 class studying piecewise functions. All right, share this out with them. Share the wealth, right? And yeah, grab a copy of my book off Amazon, How to Use All This Math, Volume 1. All right, and I'll see y'all on the next video. Peace.